Good day everyone and welcome once again to my channel. This time we are going to be having series of questions in chemistry for those that are preparing to writing the forthcoming Post-Utme examination for various institutions. So this question cuts across to different institutions and their respective past questions and even the questions you will be expecting to be tested on. So just sit tight and follow through as I run through the series of the different questions that we are going to be considering in this video lesson, and it will be of help to you. So that's the more reason why you should get your pen and your paper and jot down points, as I'm going to be unraveling so many things with regards to how to tackle questions pertaining to post-UTME in chemistry. On the board, we are having question 1, and the question is, what is zeolite? Now, you see this zeolite is actually mentioned in a part of chemistry topic which is known as how to remove permanent hardness of water. And we have different methods for removing permanent hardness of water. We have the addition of caustic soda, which is sodium hydroxide, NaOH. Then we also have the addition of washing soda, which is sodium carbonate decahydrate, that's Na2CO3.10H2O. And then we still have the permutate and the zeolite method. Now, they are asking us for what zeolite is. Zeolite is actually an aluminium oxide combination with silicon oxide and a metal. So if I would want to write the formula, then I should write it as M representing the metal, and then I can put a subscript here to indicate the number I'm to attach to it, and then AlO2, then dot SiO2, then I can put a letter here, maybe even Y, and then put, let's say, X here, and then dot, I can put, let's say, B here, BH2O. So this can be used to representing the formula of zeolite. The basic thing about zeolite is that it contains this aluminium oxide in combination with silicon oxide, and then it forms what is known as aluminosilicate. And then you now have water of crystallization attached to it. So in that case, since of crystallization is attached to that compound, then it means the compound is hydrated. Because even when you study your salts very well, one of the properties of salts happens to be efflorescence. And efflorescent compounds usually contain water of crystallization, meaning that dot H2O. Now, efflorescent compounds are also called hydrated compounds, because the moment you add water to a substance, you are hydrating the substance without water causing any form of chemical changes on the substance or altering the chemical properties of the substance. So looking at that, this can be a representative of the formula of zeolite. So it's obvious that when you combine both here, you can get aluminosilicate. Alright, so since you have water attached to it, is hydrated form of aluminosilicate. So the correct option is option A. Then let's see question 2. Question 2. Which method can be employed to test the hardness of water? Which method can be employed to test the hardness of water? They didn't say which method can be employed to removing hardness. They only said to test, to know if water is hard. That's what they are asking us. So how can we know if water is hard? Of course, water is said to be hard when it does not easily lather or foam with soap. That's how you can know whether water is hard. Because you cannot touch water to know whether it is hard water or soft water. No. You can only test whether it is hard by using soap. So if it does not easily form lather with soap, or it does not foam with soap, then such water is considered hard water. So how can you test? A. Boiling, that's not it. Distillation is not part of it. Formation of lather with soap is part of it. That's what will show whether water is hard or soft. So the correct option is option C. Then question 3. Chili saltpeter is the common name of dash. Chili saltpeter is the common name of dash. Now, chili saltpeter is also known as sodium nitrate. Sodium nitrate with the formula NaNO3. Why is it called chili saltpeter? Is because of the fact that this salt compound is often found in that country named Chile, and it is present in a desert in Chile which is known as the Atacama Desert. Alright, we still have other saltpeters, like we have the India saltpeter known as KNO3. Then we have the lime saltpeter known as CaNO32, which is calcium nitrate. Alright, so since the question is chili saltpeter is the common name of A, sodium nitrate, of course that's the answer because this is the formula of sodium nitrate. Option A is the answer because option B is potassium nitrite, which is wrong. Potassium nitrate, option C, which is also wrong because like I said, potassium nitrate is what? Indian saltpeter. Then sodium nitrite is also wrong. Please, you must be very careful when you are checking your options because there are some options that seems to be the same but they are not the same. In the case of this kind of options that we are having in this question, now sodium nitrate is in the option as well as sodium nitrite. Sodium nitrite is written as NaNO2. This is sodium nitrite. In fact, nitrite, they are known with their NO2 radical, while nitrate, they are known with their NO3 radical. So nitrate is NO3 while nitrite is NO2. So never should you mistake one for the other. Alright, so the correct option, of course, is sodium nitrate. Then let's see question 4. Question 4. Which of the following is not soluble in water? Which of the following is not soluble in water? This is taking our minds to solubility rules of salt, meaning that there are some salts that are soluble while there are some others that are insoluble. By soluble simply means they dissolve in water, while the others that are insoluble, they don't dissolve. So now on the board, looking at these options that are for this question 4, we are having all of them to be sulfates. All of them are sulfates. So it means that which of the sulfates would not dissolve in water is the question. So in the solubility rules of salt, let me take your mind back to salt. The solubility rules of salt, especially for the sulfates, has it that most sulfates are soluble salts. Take note of that. Most sulfates are soluble salts. When I say sulfates, I'm talking about salts that possess SO4 ending them. Meaning in their formula, what ends the formula is SO4, that's sulfates. So most of them, they are very soluble in water, meaning they dissolve. The only ones that are insoluble of the sulfates are three. And what are they? We have the lead, PbSO4, we have the barium, BaSO4, and we have the calcium, CaSO4. So these ones are the only insoluble. They are the insoluble sulfates. As a matter of fact, amongst these three that are insoluble, there is even one that dissolves slightly or sparingly in water, and that one is calcium sulfate, but it is still considered as insoluble, while the others, they are soluble. So we can easily get our answer now. A, lead sulfate. It's obvious it's lead sulfate because lead sulfate is PbSO4. So this should be our answer because they said the one that is not soluble. Others are soluble. Zinc sulfate is soluble. It falls under the amongst others that are, soluble. Then potassium sulfate and sodium sulfate, they are as well soluble. As a matter of fact, any salt that possesses potassium or contains potassium, it contains sodium and it contains ammonium. Take note of this. Any salt with these three things that I made mention of, they are soluble salts. Meaning any salt with Na, any salt with K, or any salt that contains NH4, just know that such salt compound is soluble salt. So let's see the next question. What is the product formed when sodium bicarbonate is heated strongly? First thing first, what is sodium bicarbonate? Sodium bicarbonate is also known as sodium hydrogen carbonate with the formula NaHCO3. This is sodium bicarbonate. That's the formula. So looking at this compound, the question was, what is the product formed when sodium bicarbonate is heated strongly? When you apply heat on sodium bicarbonate, being that all hydrogen carbonates they are unstable to heat, all of them, any compound that ends with HCO3 is hydrogen carbonate, and when heat is applied they get decomposed. So since you are dealing with sodium hydrogen carbonate, the three products you are to obtain would be sodium carbonate, which is Na2CO3, plus water with the release of CO2 gas. So this will be the products. If you balance the reaction, you are going to be obtaining something like this: two sodiums, then two carbons. Carbon is here and also there. Then oxygens here is 6. Here 3 plus 1 plus 2, total 6. So we have obtained sodium carbonate, sodium carbonate as one of the products. So checking the options over there, we have option A, sodium carbonate; B, sodium hydroxide; C, sodium peroxide; and D, sodium monoxide. So the correct option to the question is A, sodium carbonate, which is Na2CO3. The next question, question 6. Silica gel is a dash. Now, if you buy new products like maybe our home appliances, or maybe you get a new shoe, maybe all those canvas or boots, you notice that most times they add a substance, whitish ball like substances that will be packed to contain, it will be contained in a pack. That ball like substances, small roundish substances, they are actually silica gel, and their work is to absorb moisture, to remove water. So any agent that is able to absorb water, to remove water, to drag away water from a substance, or to prevent water from entering a substance, that substance is known as what? A drying agent. And silica gel happens to be an example of a good drying agent. So it is not moisturizer, it's not flavoring agent, it is drying agent, and it's not delicious food. That one is outside the box. So the correct option is C. Silica gel is drying agent. The formula of silica gel is SiO2. That's the formula of silica gel. Then question 7. When iron rusts, its weight dash. When iron rusts, the first thing to ask yourself is, what is the rusting of iron known as? It is simply the formation of iron 3 oxide when iron is exposed to damp or moist air. Now, you are having iron with the symbol Fe. If I should expose this Fe to damp or moist air, then I should have the formation of iron 3 oxide written as Fe2O3. Then since it's moist air, there must be presence of water vapor. So I can associate water of crystallization, which is unknown in this case, to it. So previously it was iron, but now after the rusting process, it has formed this, which is iron rust. So what do you observe? There must be an increase in the weight of the iron, because iron was alone previously here. Now it now contains other elements. So there must be an increase in the weight. So the correct answer is option B, increase in the weight. Then question 8. Hydrochloric acid is also known as dash, meaning HCl, that's the formula of hydrochloric acid, is also called dash. The answer to this question is muriatic acid. That is the answer to the question. So another name for hydrochloric acid is called muriatic acid. So the correct answer is option C. So it's not garlic, it's not picric, it's not chloric, but rather it is muriatic. Take note of that. Then let's see the next question. Question 9. The pair of compounds used as anesthetics in medicine is dash. Now option A is ether and ammonia. That's far from it because ether is used as solvent, so it's not used as anesthetic. When we say anesthetics, we are talking about what is used to make somebody to be temporarily unconscious, especially during major surgical operations. So this option A is outside it, it's not part of it. Then option B, nitrous oxide and chloroform, which is the correct answer. Now nitrous oxide is dinitrogen one oxide, which is N2O, also known as laughing gas. That's known as the nitrous oxide. Then chloroform is an organic compound and it is also called trichloromethane, which is CHCl3. So is commonly referred to as chloroform. Both of them can function as anesthetics, alright, while the others are not just part of it. So the correct option to the question is option B, nitrous oxide, which is also called dinitrogen one oxide. Dinitrogen one oxide, also referred to as laughing gas. So take note of that. Then let's see question 10. Question 10. Water gas is a mixture of, now when talking about water gas, we have diverse industrial gases. We have water gas, we have producer gas and we have synthesis gas. Now what are the constituents of these gases I made mention of? Starting with water gas. Now water gas is chiefly made up of CO and H2, meaning carbon two oxide and hydrogen gas. Then for producer gas, take note of all dis please. Producer gas is made up of CO and N2, which is carbon two oxide and nitrogen gas. Then synthesis gas is made up of CO and three molecules of H2. So what can you observe? Now in synthesis gas and water gas, you are having same constituent, but it's just that what differentiates them is that synthesis gas is having three molecules of hydrogen gas. So take cognizance of that. And again, what is constant across board? It is the CO. So in these gases, you are having carbon two oxide and not carbon four oxide. Take note of that. So let's check the option that would be the correct answer. Starting with option A, carbon dioxide and hydrogen is wrong. Why? Carbon dioxide simply means CO2, dioxide, so which is wrong. So anyone that contains carbon dioxide should be wrong. So A contains it as well as D. So let's focus on the other two. B is carbon monoxide, which is also known as carbon two oxide and nitrogen. Is that correct? No. This should be for producer because carbon two oxide, also called carbon monoxide and nitrogen. This is for producer. But they said water gas. So it should be what? Carbon monoxide and hydrogen, which is this. So the correct answer is option C. So let's quickly look at question 11. Question 11. One property of ammonia is, then option A, it is insoluble in water. Option B, it is an odorless gas. Option C, it is a yellowish gas. Then option D, its aqueous solution turns red litmus blue. Now, what is ammonia? The formula is NH3. And looking at the nature of ammonia is that ammonia is not acidic. Ammonia is an alkalinic or a basic gas. Alright, and then it is characterized by a sharp pungent smell like that of the smell of urine. And again, the gas is colorless in nature. It is colorless in nature. So let's check the options to see the one that best suits it. A, it is insoluble in water. Is ammonia insoluble or soluble? It is extremely soluble in water. As a matter of fact, ammonia is used as one of the gases that are being used for fountain experiment, which is an experiment that is conducted to determine the solubility of gases. We have ammonia as one of the gases and hydrogen chloride gas as the other. Alright, so it's extremely soluble. Option A is wrong. Then option B, it is an odorless gas. From what I've mentioned earlier on, that Ammonia is known by a sharp pungent smell like that of the smell of urine. That's the reason why when you are even in the lab and you are told to perceive whether the gas is ammonia, you don't just smell directly, you have to use your hand to wave the vapor coming out in order for you to know whether it is actually ammonia, because it has this kind of very sharp pungent smell. So that's out of it. Then option C, it is a yellowish gas. No, it is a colorless gas. So C is wrong. Then what about option D? Its aqueous solution turns red litmus blue. Of course, you know that for you to test whether this is basic is by working with litmus paper. And being that is a gas, you cannot use litmus paper to determine whether it is actually acidic or basic because it's a gas. So for it to have effect on litmus paper, you must need to wet the litmus paper, or you can work with an aqueous solution of ammonia because there must be the presence of water. That's what it means by aqueous. So when it's being dissolved in water, it forms an aqueous solution of ammonia. Then by so doing, if you now dip red litmus paper into such solution, you are to obtain blue because it is alkalinic or basic, and generally bases dey change red litmus paper to blue. So the correct option should be option D. Question 12. Bleaching powder is prepared by passing dash. Bleaching powder is prepared by passing dash. Then let's see the options. Option A, chlorine over slaked lime. Option B, oxygen over slaked lime. Option C, carbon dioxide over slaked lime. Then option D, chlorine over quicklime. Now, the only way you can obtain bleaching powder is by passing chlorine over slaked lime, and there's a reaction to back up which is given as calcium hydroxide being slaked lime plus chlorine to produce what? The bleaching powder, which is CaOCl2 then plus H2O. This is the bleaching powder. The bleaching powder. Alright. So looking at this, we have obtained our bleaching powder by simply reacting what? Chlorine. We passed chlorine gas through what? Through slaked lime, because this compound is also known as slaked lime, and then we are able to obtain that. So the correct option to this question is option A. So let's see the next question. Question 13. KMNO4 can be used as a dash: A, insecticide; B, fertilizer; C, pesticide; and D, disinfectant. The best option to go with is option D, disinfectant. Why? Now, underwater treatment process, there is a step that is called chlorination. That's the addition of a calculated amount of chlorine in order to kill germs. That process is also called disinfection. Now, if you read up that, they will tell you that when chlorine is not available to be used, you can use other strong oxidizing agents, because the thing is this: chlorine is a strong oxidizing agent. So any other strong oxidizing agents can be used in place of chlorine if chlorine is unavailable. Oxidizing agents like the K2CrO2O7, which is the potassium heptaoxo dichromate 6, and this guy on the board, KMNO4, which is potassium tetraoxomanganate 7. They can both be used as the disinfectant, because the process is also called disinfection, in order to kill germs. So the best option to go with in that case is option D. Then question 14. The gas that usually causes explosions in coal mines is, this is taking our minds to organic chemistry. That's talking about the first member of the alkanes, which happens to be methane. Methane has two names. And what are the two names? Methane can be called marsh gas, and it can also be called fire damp. Marsh gas and fire damp. Why is methane called marsh gas? It's because of the fact that methane is often seen being released or evolved or given off in swampy environments or wet environments. Then as for the fire damp, the reason why methane is also called fire damp is because it is responsible for fire disaster or explosions in poorly ventilated coal mines. So the correct option to that question is option D, which is methane. That's what is responsible for that, and that's why methane is also called fire damp. So don't forget that. Then question 15. Gold dissolves in dash. A. Aqua fortis, B. Nitric acid, C. Aqua regia, and D. Acetic acid. Now, one very important thing that you need to know is this: gold doesn't dissolve in virtually almost all acids. So option B and option D, they are out. Then the next thing is we are having option A to be aqua fortis and option C to be aqua regia. I would explain what both of them mean. Just pay attention. Now, aqua fortis is also called strong water, and it is nitric acid, which is HNO3. That's what is known as aqua fortis. This aqua fortis can dissolve metals like copper, silver, but it cannot dissolve gold. That's one uniqueness about that. So it can't dissolve gold. Then what about aqua regia? Aqua regia is simply a mixture, and it's also known as royal water. Take note of these names, very important. Now, it's a mixture of concentrated hydrochloric acid and concentrated nitric acid. And what are their respective ratios? Now, remember I said it's a mixture of concentrated hydrochloric acid and concentrated nitric acid. Then their volumes in terms of ratio is 3:1. Alright, both are concentrated. Now, one very important thing about this aqua regia, or what is so unique about this aqua regia, is that it can dissolve gold. Alright, so the correct option to this question is option C, which is aqua regia. Then question 16. The chemical name of rat poison is, I believe that this question will be kind of new to so many of you watching this video right now, but it's a chemistry question. The chemical name of rat poison is, now the correct option is zinc phosphide, having the formula Zn3P2. Now, when this zinc phosphide dissolves, or when this zinc sulfide decomposes, it decomposes to releasing a very toxic gas, which is phosphine gas. This gas is called phosphine, and it is highly toxic. So that's the reason why it's often used in rat poison or as rat poison. Alright, so that's the correct option, option D. Then question 17. Epsom salt is used, first and foremost, what is Epsom salt? Epsom salt is magnesium sulfate heptahydrate and is often used as a laxative. And what are laxatives? They are simply used to prevent constipation and also to regulate stomach ache. It tends to actually calm the stomach ache. Talking about constipation, indigestion, they are basically used for that. So let's see the options. A, as purgative. Purgative is also known as laxative, so don't be confused. So that should be our answer. It's obvious already. So option A becomes the answer. Option B is not part. In softening water, that's not part of it. Then option C, in paper industry. Option D, in making toothpaste. Those are not part of it. So the correct option is option A. So let's see the next question. Question 18. Dry powder fire extinguisher contains. Now normally you know that the gas that is commonly used as fire extinguisher is carbon dioxide, which is CO2. So now they are asking us for the dry powder fire extinguisher consists of what? A. Sand. B. Sand and sodium carbonate. C. Sand and potassium carbonate. D. Sand and sodium bicarbonate. First thing first, you cannot be having something that functions as a fire extinguisher and would not most likely be associated with carbon dioxide, which is CO2. So if it does not possess carbon dioxide or it does not contain carbon dioxide, it means most likely it shouldn't be acting as a fire extinguisher. Alright, so sand is outside, is out of it, is wrong. Sand and sodium carbonate, that won't make sense. Why? Because sodium carbonate cannot yield carbon dioxide. The reason is because sodium carbonate is stable to heat. So you are trying to put out fire and then the fire extinguisher is not carrying that CO2. It means it cannot put out the fire. So it means this guy is out. Can't get CO2 from this because it's heat stable salt compound. Then C, sand and potassium carbonate. This is still outside it because this is also heat stable. Then sand and sodium bicarbonate. Sodium bicarbonate is sodium hydrogen carbonate. And I think one of the questions we have already attempted was the decomposition of that sodium hydrogen carbonate or sodium bicarbonate, the same stuff. And then at the end, we obtained CO2 being released as one of the products. So when you heat this, you have to obtain CO2. So that's most likely to be the correct option. So the correct option is option D. All right. So that's how you attempt questions. So the basic truth of this is that you might be given a question that you might have not seen before, but with your understanding of the question and the application of knowledge that you already have about the particular thing they are referring to, you should actually be able to get your answer correctly. Then let's see question 19. Detergents used for cleaning clothes and utensils contain dash. This question is just coming from how well you understand the formula of detergent, the structure of detergent. Alright. Now, what's the structure of detergent? Detergent has this representation of arrow, that's an alkyl group, and then linked to a benzene ring and linked to a sulfonate group, and then sodium ion is present too. So looking at this arrow represents alkyls, and alkyls they are symbolized with arrow, and then I can as well say this is alkyl, then this is benzene ring, so benzene, then this is sulfonate group, so sulfonate. So that's the reason why another name for detergent is ABS, which is alkyl benzene sulfonate. So they must contain the sulfonate group. Option C is the right answer to that question. All right. Then question 20. Ozone layer of the atmosphere absorbs dash. Of course, you ought to know that ozone layer is found in the atmosphere, and the region of the atmosphere that you can find it is the stratosphere. Ozone layer is like an umbrella-like structure that reflects back ultraviolet rays coming from the sun. That's the reason why we don't get the direct ultraviolet rays. We actually get just a fraction of sunlight, and it's due to the fact that there is ozone layer that reflects back the ultraviolet rays. So the correct option to this question is option A. The rest are wrong. Then question 21. The metallic constituent of hard water are. I would need to explain this very, very well. The metallic constituents of hard water. Normally, if we say hard water, from what I have explained previously, when water is said to be hard, it means it cannot easily foam with soap. That's what it means, meaning it weighs soap. You'll be trying to get foam from the soap, and then it will be very difficult. Now, hard water, we have two types of hardness. We have the temporary we have the temporary and we have the permanent. So these are the two types of hardness: temporary hardness, permanent hardness of water. For temporary hardness, it is caused by these salt compounds: calcium hydrogen carbonate and magnesium hydrogen carbonate. Then the ones that can cause permanent are we have the magnesium sulfate, we have the calcium sulfate, we have the iron sulfate, we have the calcium chloride, we have the magnesium chloride. So these are the different causative agents or what can result in the formation of permanent as well as temporary. Now, if you check all of these, the ions that you can single out here includes magnesium, calcium, iron, calcium, magnesium. So if you are bringing all the metallic ions that can cause hardness, they include magnesium, calcium, and iron. So these are the three ions that can cause hardness. So let's check the options. Option A, magnesium, calcium, and tin. This is wrong. Option B, iron, tin, and calcium. Very wrong. Option C, calcium, magnesium, and iron, which is correct. Calcium, magnesium, and iron, which is correct. The option D is wrong. So the correct option is option C. So let's see the next question. Question 22. Which among the following options is suitable indicator when solution of sodium carbonate is mixed with sulfuric acid? Now, this question is coming from a reaction of acid on triazocarbonate. Now, the triazocarbonate mentioned is sodium carbonate and the acid is sulfuric acid. Now, H2SO4 is the formula of sulfuric acid. And this acid, is it a strong acid or a weak acid? Is a strong acid. Alright. Then sodium carbonate, which is Na2CO3, is a weak base. Now, one very important thing that you need to know is this: the most suitable indicator or the most suitable indicator to be used of a reaction between strong acid versus weak base is methyl orange. Methyl orange. Then what about strong acid versus strong base? Any indicator can be used. Any indicator. Then weak acid versus strong base. The best indicator is phenolphthalein. Take note of all these o, very important. Then while weak acid versus weak base, there is no suitable indicator to be used. So take note of that. Just take note. So let's check the options. A, methylene blue, B, methyl red, C, phenolphthalein, and D, methyl orange. So what category does this one belong to? It falls under the strong acid versus weak base. And strong acid versus weak base is methyl orange. So the best option to go with is option D, methyl orange. That's the correct answer to the question. So the next question, question 23. In question 23, we were told that soap is prepared by boiling caustic soda with dash. Soap is prepared by boiling caustic soda with dash. Now, this question is coming from saponification. That's the soap production in organic chemistry 2. And what's saponification? It's a process that involves the alkaline hydrolysis. When I say alkaline hydrolysis, it simply means it involves the use of a caustic alkali, and that can come in the form of potassium hydroxide or sodium hydroxide. And then you are using that to cause the hydrolysis of fats and oils. So we are told soap is prepared by boiling caustic soda. Caustic soda is NaOH, and that's actually the caustic alkali with, of course, it should be what? Fats, from what I said. So that's the correct answer to the question. Then question 24. The chemical name of milk of magnesia is, the chemical name of milk of magnesia is, if you have studied your basis thoroughly, you tend to know that milk of magnesia has the formula MgOH2, which is magnesium hydroxide. So do we have that in the option? Let's check. A, magnesium carbonate is out of it. Then B, sodium bicarbonate, that's totally wrong. C, calcium hydroxide is wrong. Option D, magnesium hydroxide. So the best option is magnesium hydroxide, option D. Then question 25. Table salt gets moist during rainy season because you know what table salt is now? Table salt, the formula is sodium chloride. That's our table salt, the salt we use in cooking at home. Table salt gets moist during rainy season because now first and foremost this sodium chloride is not an hygroscopic substance and it is not a deliquescent substance. So it means that it does not get wet being that is hygroscopic or deliquescent. It's neither of them. Then let's check the options. A, sodium chloride is hygroscopic, which is wrong already. Then B, sodium chloride is deliquescent, is also wrong. Then it's now between C and D. C, sodium chloride contains some quantity of sodium iodide, and D, sodium chloride contains hygroscopic impurities like magnesium chloride, which is the correct answer because now it's because of the magnesium impurities as in the form of magnesium chloride that makes it to absorb water, because remember magnesium chloride is simply a deliquescent substance, but of course all deliquescent substances are hygroscopic substances, alright, meaning that there must first be the absorption of water when they are exposed to the atmosphere before they would not dissolve to form solution. So it's due to the presence of that guy in sodium chloride that makes it to become moist during rainy season. So the correct option is option D. Then let's see question 26. Question 26. Which of the following gases is present under pressure in soft drinks? When you just hear of any gas that should be present in soft drinks, just know that the gas must be carbon dioxide or CO2 or carbon dioxide. Alright, so option A is oxygen, B nitrogen, C carbon dioxide, D nitrous oxide. Correct option is carbon dioxide, which is CO2. As a matter of fact, that's the gas that is actually responsible for giving our soft drinks their sharp, refreshing taste, and also that fizz, that spluttery sound that you hear when you are turning the drink into a glass cup, or when you hear that sound when you open the cork on top of the bottle, then of course that is still responsible for that sound, which is the CO2. All right, so let's see the next question. Question 27. What is the chemical name of baking soda? Now baking soda has a chemical formula, and the chemical formula of baking soda is sodium hydrogen carbonate. Never should you mistake this for baking powder. Now baking powder is a mixture of baking soda, which is sodium hydrogen carbonate, and tartaric acid. So when you mix these two, you are to obtain baking powder. So what is NaHCO3 called? It is called sodium hydrogen carbonate, or you call it sodium bicarbonate. Alright, so what's the chemical name of baking soda? Is it sodium carbonate? This is wrong. It's sodium bicarbonate, which is right. The other two are out. They are not part of it. Then 28. Question 28. Which of the following statements is or are correct? A. Oxides of non-metals are basic. B. Oxides of non-metals are acidic. C. Oxides of metals are acidic. And D. All options are correct. Let's confirm something. They only mentioned oxides of metals, oxides of non-metals. Let's focus on those two. For oxides of metals, we have classical examples like the Na2O, CaO, K2O. These are oxides of metals and they are basic oxides. How are they basic oxides? Because judging from the 5 types of oxides that we have the acid oxides, we have acid oxides, we have basic oxides, we have neutral oxides, we have amphoteric oxides, and we have peroxides. Alright, peroxides. Now, acid oxides, they are oxides of non-metals. Let's focus on the oxides of non-metals now. Oxides of non-metals are, we have classical examples, NO2, SO2, CO2. All these are oxides of non-metals. because nitrogen, sulfur, and carbon, they are non-metals. So oxides of non-metals are called acid oxides, or you can call them acid anhydrides. That's another name for acid oxides. Acid anhydrides. All right, they are oxides of non-metals. Then basic oxides, they are oxides of metals. Then neutral oxides, they are simply oxides that neither possess acidic nor basic properties. So classical examples of neutral oxides include CO, that's carbon monoxide. We have a dinitrogen 1 oxide, which is commonly referred to as laughing gas. Then we have even water too. Water is an example of neutral oxide. Amphoteric oxides, they are direct opposite to neutral oxides in that amphoteric oxides, they possess both acidic and basic properties. Classical examples of amphoteric oxides include the zinc oxides, the aluminum oxides, the tin oxides, the lead oxide, even beryllium oxides. Now, those are special metals that form amphoteric, talking about aluminum, zinc, tin, lead, and beryllium. They are oxides, they are amphoteric. All right. Then, for that of peroxides, they are simply compounds that the oxidation number of oxygen is -1 in such compounds. In most compounds, remember that the oxidation number of oxygen is -2, except the peroxide, which happens to be -1. So we have sodium peroxide, potassium peroxide, even hydrogen peroxide too, which is H2O2. All right. So oxides of metals, they are basic oxides. Oxides of non-metals, they are acid oxides. All right. So which one would be the best option to go with? Oxides of non-metals are basic. No, they are acid oxides. So oxides of non-metals are acidic. So the best option is option B. While oxides of metals, they are what? Basic. So this one is wrong. These two, they are wrong. Then the last is wrong. So the best option is option B. Then let's see question 29. Question 29. In modern periodic table, the atomic radius increases dash. In modern periodic table, the atomic radius increases dash. Let me analyze this question. Now they are making reference to a particular periodic property of elements, and that is atomic radius. Now, these are the periodic properties of elements. I will enlist them now. That's the reason why I said you should pay close attention to this video to be of help to you, especially the explanations. Now, periodic properties of elements, what are they? We have the first to be electron affinity. We have electron affinity. Then we have ionization energy. Ionization energy. Then we have atomic radius. This is the main one that they are asking questions about. Atomic radius. Then we have electropositivity, electropositivity and electronegativity. Now, what's their trend in the periodic table? For electron affinity is IAP and DDG. This is like a code that we explain. This one is still IAP and DDG. While atomic radius and electropositivity, they are both DAP and IDG. I will explain all this. DAP and IDG. Then while the last one is IAP and DDG. Now these things, they represent something. When you see IAP here, it means increases across the period, meaning you are moving from left to right. That's across the period. And decreases down the group, meaning from top to bottom down the group. Then ionization energy is same stuff. Then for atomic radius and electropositivity, is decreases across the period, meaning that it decreases across the period from left to right, and it increases down the group, meaning from top to bottom. So let's focus on this guy, which is the atomic radius. It decreases across the period. It decreases when it is decreasing. When it is decreasing across the period, then it means it is decreasing from left to right. That's what it means. It is decreasing from left to right, meaning in a period. So if it decreases from left to right, Then if you are now moving from right to left, then it should be increasing. Because if you say that something decreases from this point to this point, or from point A to point B, there is a decrease, then it means that if you are coming from point B to point A, there should be what? An increase. You understand the point? It's just like you saying that 3, 2, 1, there is a decrease from left to right here. But if I am moving from right to left, there is what? An increase. That's what I'm trying to explain. All right. So it means atomic radius will decrease across the period, meaning it will decrease from left to right, and then it would increase from right to left. It's still same stuff. All right. So let's check the options. A, while moving from left to right in a period, does it increase? No, it decreases. It decreases from left to right. Then B, while moving from right to left. So it means that it increases from right to left. Hope you got that. So it's very easy. It decreases from left to right and it increases from right to left. So the best option to go with, since they are talking about period and not group, so is option B. So take note of that. Then question 30. Incomplete combustion of a fuel gives poisonous dash gas. Incomplete combustion of a fuel like petrol, it gives dash poisonous gas. So what's now the gas that you can obtain by incomplete burning of fuel? The gas that you can obtain is CO. Incomplete gives CO, but complete would give CO2. And what's CO? Carbon monoxide. So and it's actually a toxic or poisonous gas. So option C is the right answer to the question. Let's see the next question. Question 31. Which is not an inorganic gas? This question is actually asking for the one that would be probably an organic gas because it's not. So if you check the options, option A, ammonia. Ammonia happens to be an inorganic gas. So this one is out already. Then hydrogen sulfide is still inorganic. Ammonia is NH3, hydrogen sulfide is H2S. These are inorganic gases. So it's wrong. Then methane is CH4. CH4, that's an organic gas. So it's not an inorganic gas. It falls under organic compounds, organic chemistry, talking about the alkanes. Remember that the first four members of the alkanes are gases. That's methane, ethane, propane, and butane. The first four, they are gases. Then option D, carbon monoxide, CO, is inorganic. So the correct option is option C. Then let's see question 32. The nucleus of a hydrogen atom consists of, focus on this word, nucleus, nucleus. Now what makes up the nucleus of an atom? The nucleus of an atom is made up of what? The proton and the neutron. But now, what did they ask of hydrogen atom? Remember that hydrogen atom could be either H11, H21, or H31, talking about the isotopes. But since they were not specific about the particular isotope of hydrogen, you should go with the most abundant isotope, which happens to be the H11. So looking at this isotope, the nucleus of this hydrogen should be having what? It should be having one proton, which is this guy, and how many neutrons? Remember, for you to obtain neutrons, you have to subtract the proton from the mass. So that gives us what? 1 minus 1, which will be 0 neutron. So it means it does not contain any neutron. It only possesses what? Just one proton. So it's one proton only, which is option A. All right. Then let's see the next question. Question 33. In the modern periodic table, metals, metalloids are also called semi-metals, and non-metals are found in which block? So let me just show you like an abridged version of the periodic table indicating the blocks of elements. Now, looking at the abridged version of the periodic table, that's a smaller version of the periodic table, we have something like this, and then we have this. Now, this is hydrogen, helium, then lithium, beryllium, then boron, carbon, nitrogen, oxygen, fluorine, neon, then sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, then potassium and calcium. Now dis group one, dis group two, group three, group four, group five, group six, group seven and group eight. Now looking at dis groups, group one and group two elements are s block, meaning that their orbital representation ends in the s orbital, alright. Den group three to group eight, they are p block. I think that's where our answer would be. From dis three to eight, they are p block, and if you should check, we have metal, which is aluminium in dis case, metal. We have boron and silicon to be metalloids, and then we have non-metals to be these guys over here. So we are having non-metals, metals and semi-metals. So it's obvious that the group three to eight are the p block, and of course they consist of these elements: metals, non-metals and metalloids. So option B becomes the right answer. For the F block, they are the inner transition elements or metals, talking about lactanate and actinide series. Then D block are the transition elements, looking at scandium all through to zinc. They are D block elements. Alright. So the one that consists of the three groups of elements happens to be the P block. So that's the answer to the question. Then 34. During galvanization, which metal is used for coating iron and steel objects, preventing them from rusting? The word galvanization is coating a metal with zinc. Alright, so it means the metal that is being used during galvanization is zinc. Don't forget that. Alright. Then question 35. Which of the following metal is most ductile in nature? Now, amongst these metals given, option A copper, option B silver, option C gold, option D aluminium. One very important thing that you need to take note of is this: the word ductile means ability of a metal to be drawn into thin wires. We have malleability and ductility. Malleability is the ability of a metal to be hammered or beaten into different forms or shapes. And as a matter of fact, the most malleable, and most ductile metal is gold. Take note of that. Gold is the most malleable and ductile metal, and it even happens to be the king of metals. So if you are asked which element is referred to as the king of metals, I didn't say king of elements, I said king of metals, it is still gold. So let's see the next question, because the correct answer to this question now is option C. 36. Substances which are generally bitter in taste and feel soapy on touching are known as dash. Dis question is suppose to be a very cheap one. Why? When you have studied the physical properties of bases, den you'd be able to get the answer to dis question correctly. Dat one of the physical properties of bases is dat bases are soapy to touch, and also they are generally known by their bitter taste. Unlike acids they are known by their sour taste, alright, especially dilute acids. So the correct option to dis question is obvious, is what? Bases. Bases are generally bitter in taste and they feel soapy on touching. Den question 37. Which among the following acids is used in lead storage batteries? Now, lead storage battery is an example of secondary cell. We have primary cells and we have secondary cells under electrochemical cells. The primary cells, they are not easily rechargeable, cannot recharge them. Then for that of secondary cells, you can recharge. And classical examples of secondary cells includes the lead acid accumulator, even your phone batteries. lithium ion batteries. Of course, it is an example of secondary cell. So the acid that is present in lead acid accumulator or lead storage batteries is H2SO4, which is sulfuric acid, option C. That's the right answer to the question. Then the next question, question 38. The octane number of 0 is assigned to dash. Now, what are the two standards? Having octane number of 100 and having octane number of 0. Now, what it means is that any petroleum product that has an octane number of 0, it means that such petrol is of low quality. Then of 100, it means it's of high quality. So this is the standard that is being used to measuring the quality of petrol. Now, when petrol is of low quality, it can result in the knocking of engines. Alright. Then which compound possesses octane number of 100? It is 2,2,4 trimethyl pentane, which is also known as isooctane. Alright. Then while that of octane number having it to be 0 is present in N-heptane, which is normal heptane. So the correct answer to this question now should be option B. While isooctane has an octane number of 100. So don't forget this explanation. Alright. Then the next question, question 39. An amalgam of metal has which other element? Meaning that let's say A is a metal and then an amalgamated form of A is written as AX. They are asking us what should be X, because already A is a metal and it has combined with X to form an amalgamated form of A. So what should be X? Of course, what can actually amalgamate a metal is mercury. Alright, so mercury Hg, when it combines with a metal to form the amalgamated form of the metal. A classical example is seen in sodium amalgam, which is amalgamated sodium. So the correct answer to this question is option D. When you just hear the word amalgam and then in combination with a metal, just know what is combining with that metal must be mercury. So don't forget that. And of course, the symbol of mercury is Hg. Then let's see the next question. Question 40. The high reactivity of fluorine is due to dash. Fluorine is seen to be the most reactive element in chemistry. And what makes it to be very reactive is because of its high electronegativity. As a matter of fact, the most electronegative element so far in chemistry happens to be fluorine, while the most electropositive is francium. And of course, being that francium is the most electropositive, that's what invariably now makes francium to be the most reactive metal. Then fluorine is the most electronegative. Then of course, that's what makes it to be the most reactive non-metal. And as a matter of fact, when even making comparison between the reactivity of fluorine with that of francium, fluorine is seen to be more reactive than francium, automatically making fluorine to be the most reactive element in the world of chemistry. So it's due to its high electronegativity, which is option A. That's the right answer to the question. So let's see the next question. Question 41. What is formed when magnesium is burnt? Now, when you burn magnesium, what are you to obtain? Mg is the symbol of magnesium. Then burning it in oxygen, you are to obtain magnesium oxide with the release of energy. And the energy is usually in the form of light energy as well as heat energy will be released in the process, because the reaction is highly exothermic, meaning it involves the release of heat. Now, looking at this reaction, okay, balancing this, it ought to be written like that. Now, they are asking us what is formed. This is the main thing that is formed in the reaction, which is magnesium oxide. A, baking soda, that's not it. This is wrong. B, calcium carbonate is also wrong. Then C, hash, and D, vinegar. Vinegar is wrong. Hash is correct. Why? Because this compound is also called white hash. So take note of that. So that's the reason why the correct answer to this question is option C. Then question 42. Which product is produced along with a salt in an acid-base reaction? An acid-base reaction is also called neutralization reaction, and it involves the reaction of an acid with a base to form what? To form salt and water only. So looking at this reaction now, they are like, after the formation of salt, which other product would you still get? It is water. So checking the options, the only option that carries water is option D, which is the right answer. That question is a very cheap one. Then let's see question 43. Question 43. What is dry ice? What is dry ice? Dry ice is simply solid CO2, meaning solid carbon dioxide, which is often used as a refrigerant for perishable products like our ice cream. Alright, so let's check. A, solid carbon dioxide. Carbon dioxide is also called carbon dioxide. That's one very important thing that you need to take note of. Carbon dioxide is also called carbon dioxide. All right. So the correct option is option A. No need to check the others because carbon dioxide or carbon dioxide is solid CO2. And as a matter of fact, if you have read separation techniques for mixtures under sublimation, now examples of solids that sublime includes dry ice, which happens to be this. Of course, we have others like ammonium chloride, naphthalene crystals, iodine crystals, and this guy. All right. So let's see the next question. Question 44. Charcoal is used in water treatment as a dash. First and foremost, when we talk about water treatment process, there are processes that are involved in the purification of water. We have the first to be coagulation, which is also known as flocculation. That process involves the addition of alum in order to gather the fine sediments or debris that are present in the water. Then the next step is sedimentation, which involves you pouring the water into a settling tank in order to have two layers, upper clear layer and then the lower layer that contains the big flock or the sediment. And three, we have filtration. Filtration talks about the use of filter bed that consists pebbles, stones, gravels, and then you could also include even activated charcoal. Now, when we say activated charcoal, it means you are subjecting charcoal to a very high temperature by heating, and then you treat chemically by simply introduction of pore spaces in the charcoal. Now that charcoal will help to perform two duties. And what are the two functions? First function, which is the most relevant function, is that it helps to remove odour from water, and then the second, which is considered as minor, is that it tends to help in improving taste of water. So how does it do this? It actually does that by acting as or functioning as an adsorbent. I said adsorbent, I didn't say absorbent. Listen attentively. The word absorb and the word adsorb, they are different. Absorb means to penetrate or to go in, while adsorb, the one with the D, means to remain on the surface or to get trapped. Let me make it very clear. Now, if I'm having a foam, you know what a foam is. If I dip that foam into a bowl of water and then I bring out the foam, now the water penetrates the foam, meaning it goes inside the foam. That is absorb, the one with the B. What about if I place a magnet close to a metallic object? That magnet will trap the metallic object on its surface. So since that metallic object remains on the surface of the magnet, then of course the magnet is adsorbing the metallic objects. You get the point now? So it means to remain on the surface or to get trapped is the one with the D, that's adsorb. Then while to penetrate or to go in is the one with the B, which is absorb. So activated charcoal would be functioning as an adsorbent because it tends to trap. it does not allow the penetration, it only traps. Alright, so it functions as an adsorbent. So this is the correct answer, adsorbent. Take note of that. Den 45, which one of the following is known as the brown coal? Now, looking at coal, coal is an example of amorphous carbon, meaning non-crystalline carbon, and it was obtained in the Carboniferous period. That was where coal was obtained, in the Carboniferous period. In this period, there was just earth movement that resulted in the felling of vegetations and then decomposition taking place, and then resulting in the leftover of dark deposit, which was later named as coal. Then this coal occurred in different stages, and it was these stages that were named the types of coal, and they are about four. The stages of appearance of coal includes: first, the one that appeared first in the Carboniferous period was peat. Then the next that appeared was lignite. Then the next that appeared was bituminous coal. Then while the last that appeared was anthracite. Alright, so these are considered to be the four types of coal: the peat, lignite, bituminous and anthracite. As a matter of fact, lignite is also called brown coal, and the coal that is abundant in Nigeria is lignite. So sometimes they might just say that lignite is considered as Nigerians coal. Alright, so take note of that. Brown coal is lignite. Then bituminous is also called soft coal. Then anthracite is called hard coal. Hard coal. As a matter of fact, anthracite is also considered to be the purest type of coal, because it contains the highest proportion of carbon content. So take note of that. Alright, so these are the types of coal. The one that is of highest impurity and lowest carbon content is peat. Then while the hardest and the purest type of coal is anthracite. Alright, so with these explanations, then you'll be able to get your answer very, very well. Now, which one of the following is known as the brown coal? It's obvious now that the brown coal is lignite. So the correct option is option D. So let's see the next question. Question 46. Which one of the inert gases can form compounds? Now, this question is a bit tricky, because if you must have read about the inert gases, talking about the noble gases, they are the group 8 elements, and they are said to be relatively inert in that they are unreactive. They do not form compounds easily. Why? Because they are not in need of electrons, and they do not give out electrons. They are relatively stable in that they are in obedience to the octet and duplex rule of stability. But there is a particular element of the group 8, talking about the noble gases, that forms compounds, but it does not really form much compounds. It only forms compounds with highly electronegative elements like fluorine and oxygen. And there is a reason why it has to form such compounds. It's because of the fact that it has a large atomic size and a relatively low ionization energy when compared to others of the series, and it happens to be xenon. Now, xenon is seen to form compounds Ze or Xe rather, Xe. This Xe is able to form compounds with fluorine and oxygen. Alright, now you could be having compounds like XeF2, XeF4, XeF6. Now this is called xenon difluoride, while this is xenon tetrafluoride. because tetra stands for 4, fluoride. The last is xenon hexafluoride, which is 6. Then we still have some compounds that xenon can form with oxygen, like XeO3 and XeO4. This is called xenon trioxide, while this is xenon tetraoxide. So all these compounds can be formed by xenon. So xenon is a noble gas or an inert gas that can form compounds. So the correct option is option B. Then the next question, question 47. The resources which can be used continuously, meaning it is sufficiently supplied, it does not get finite, it does not get to an end, it's continuously supplied year after year, are called renewable resources, or you could say renewable energy. I would want to make comparison between renewable and non-renewable. Now, opposite to renewable goes to non-renewable. Simply means for non-renewable, they can be used up and exhausted over time. But in the case of renewable, they are continuously what? Replenished, or they are continuously replaced. Now, talking about renewable, some of the renewable energies that we have and the non-renewable resources or energies that we have. For renewable, you should be talking about solar energy. Solar energy is an example, even that of wind. Wind energy is an example of renewable. Even hydro energy. Hydro, talking about energy obtained from water. Even geothermal, talking about the heat that is generated from the earth crust, geothermal. And talking about biomass, you can either call it biomass or you call it biofuels. Biofuels. Alright, these ones you can obtain them from alcohol in the form of ethanol, you can obtain them from wood, you can obtain them from even biogas too. So all these are renewable. Then for non-renewable, you are talking about all those fossil fuel like coal, talking about oil, talking about petroleum products. You understand? Petroleum products. Then talking about even nuclear energy that are generated from a fission reaction of uranium or even plutonium. You understand? Those are actually under the non-renewable. All right. So they fall under that category. So from the question now, they said the resources which can be used continuously year after year are called renewable. So take cognizance of that. So the next question, question 48. Question 48. Chemically, quicksilver is known as mercury. So take note of that, that mercury is also referred to as quicksilver. That's the answer to that question. I guess some students will be tempted to go in with silver, but it's not correct. It's actually mercury that is considered as quicksilver. Then question 49. Two elements which are used to absorb, keyword absorb neutrons to control the chain reaction during nuclear fission are now boron and cadmium rods. They are being used as neutron absorbers, meaning that they stop. So their function is to stop fast moving neutrons in nuclear reactors or atomic piles during nuclear fission chain reaction. Alright, so they are to stop. Neutron absorbers, basically they stop fast moving neutrons. Then we still have the other ones that are considered as neutron moderators. Never should you mistake neutron moderators for neutron absorbers. Neutron absorbers dey stop, while neutron moderators dey slow down. Alright, so dey slow down. Classical examples of neutron moderators, we have the deuterium oxide, which is also known as heavy water. Deuterium oxide, because it's formed from the isotope of hydrogen, deuterium, which is referred to as heavy hydrogen in combination with oxygen to form the D2O. This is called deuterium oxide or you can refer to it as heavy water. Heavy water. Then you also have another which is graphite. Graphite can as well function as neutron moderator also. Alright, so take cognizance of these examples, they can still be of help to you. So the correct answer to that question should be option A, which is boron and cadmium, because the question was to absorb. So we are referring to neutron absorbers, and these are the two that are often used to stop fast moving neutrons. So let's see the next question. Question 50. Question 50 says the percentage of pure gold in 18 karat gold is. This type of question will be very confusing to so many students, but let me just explain this. Now, what is the real standard indicating 99.9%, approximately 100% gold? What is that standard in terms of carat of gold? It is 24 karat gold. Now when you hear 24 karat gold, know that it has about 99.9% gold, which is approximately what? 100% pure gold. That's what 24 karat symbolizes. So this is considered to be the standard. Alright, so if they are now asking us to calculate or find the percentage of pure gold in 18 karat. So since this is the standard, we can easily obtain it. How? Now 18 karat should be 18 over 24 being the exact standard, then times what? 100. You get the point. So from here we can easily obtain our answer, right? Because if 24 karat would be equivalent to 100%, then what should be 18 karat equivalent to? Of course, you ought to know that when you cross multiply, you can use this normal linear pattern. It will still result in this. When you cross multiply, it will now be 24 times x, which is 24x, equal to what? 18 times 100, that's 18 times 100. When we do that, we have to divide both sides by 24 to get the x, which is still same as this. This and this, they are the same. So it becomes what now? When we do it with the help of our calculator, we are supposed to obtain that 18 times 100 should be 1800, then divided by 24, we should obtain 75. 75. So 75% is the answer to the question. So option B is the answer to the question. So we have come to the last stage, or we have come to the last question. We have attempted the last question under this series. So it's with my hope that you've been able to understand something in this series. If you know that you are still finding some aspects difficult, I would advise you to revisit the video and watch over and over and over again until you master every step and every explanation that I have dropped in this video. If you find this video helpful, I would love for you to give that thumbs up button, which is the like button, and you should also be a subscriber to this channel if you are yet to subscribe to this channel in order to get the very best. Also, if your friends are unaware of this channel, you can do well to share the channel link to your friends for them to be able to benefit just like the way you are benefiting. I wish you guys all the best and stay glued to this channel because more are yet to come. Thanks for watching.